Hi everybody, welcome to my talk. Today I'm going to be talking about the ways in which the VPC private gateway can be used and just how its functionality can be improved. Okay, a bit about myself. I'm a developer at ShapeBlue. Been a Java developer mostly for about 10 years. I've been working in the areas of the medical insurance, switch payment systems, and telecommunication billing systems. I live in Cape Town. That's a photo of me doing some trail running on a mountain. And yeah, I'm a relatively new contributor to Cloudstack, and also even newer contributor to networking. So yeah, please bear with me. So why am I doing this talk about the VPC private gateway and its improvements? Well, when I started as a Cloudstack developer, I did a lot of investigation and research into just how does Cloudstack work, and specifically I investigated how networking and VPNs and VPCs work in Cloudstack itself. So during my investigation and experience with ShapeBlue, I found that there are some shortfalls and limitations that when it comes to using the private gateway, specifically to peer many VPCs with each other. So I would like to talk you through what those problems are, and also we'll look at a problem use case which we found at ShapeBlue and that we encountered with one of our customers. And so I'll just highlight those problems as we go through that use case. And then at the end, what I'll do is I'd like to propose and share some ideas that we have, that we've come up on a whiteboard session. So these are just basically ideas. It's not a pull request yet or anything like that. So there's no FR for it either. So what I'm hoping to do is just to share with you some ideas and also to get some feedback from you guys. So what we'll do to set the stage is just to give a quick overview of the VPC and VPN as it relates to the private gateway. And also, I'll give an overview of the private gateway itself. I'll point out some characteristics, advantages, and disadvantages of each. And then what I'll do is we'll look at the problem. And then, as I said, I'll highlight the limitations and drawbacks that we're currently experiencing. And then lastly, I'll get to share the ideas, and then we can talk more about that. So, first of all, let's firstly just recap what the VPC is and what it does. The VPC is a private network. So it consists of tiers. Now each tier has its own subnet, and you can resemble a traditional network topology with using VPC and tiers. For example, your web app, application, and database tier. Then also regular users are able to create a VPC. And a VPC in the cloud can take advantage of course, the underlying scalable infrastructure as opposed to using your own equipment. And it's also a logically isolated part of Cloudstack. Users can set up access controllers, and these rules allow or deny traffic rules that allow or deny traffic between tiers and also public networks. The routing between these tiers is done via the VPC virtual router. Load balancing can also be set up to load balance between traffic. For example, in your web tier, you can load balance between the VMs in that tier. So how do I access VPCs externally? Other than just port forwarding. What I can do is first of all, I can set up various types of VPN connections. For example, site-to-site VPN, VPC to VPC VPN, and then also user VPNs for road warriors and so on. Now let's quickly look at some VPN characteristics. The VPN is a software-based tunnel. It routes data securely over the internet, as shown there. And also it routes data by encapsulating and decapsulating data. So the advantage of using the VPN is that it's quite straightforward to set up. And also, since traffic is routed via the L3 IP layer level, regular users are able to set up VPN connections themselves. But the drawbacks are that VPN tunnels are dependent on the public network, so they tend to drop. And also, you need to manually bring them up when it goes down. So since packets need to be encapsulated and decapsulated and routed over the internet, latency is, of course, an issue. And also, VPN does not support certain network features like jumbo frames and so forth. So now let's look at let's look at the VPC private gateway. Why it's a stealthy ninja, but only a brown belt at the moment. And let's look at what it can do. So the VPC private gateway is an interface that gets created on the VPC router. It is used to create a direct connection between two private networks. The ingress and egress traffic between these networks are routed through the virtual router private gateway interface. And also the traffic is routed via the private connection shown in red over there. And it does not use the public network. So there's no need to set up VPN connections using the private gateway. But also the private gateway must be set up by root admins, and this is because they need to specify what VLAN needs to be used. So regular users are not able to set up these private gateways. But what they can do is afterwards they can go ahead and add static routes to the private gateway. So why do we use the private gateway? Well, when users need a dedicated private connection that needs to be fast and reliable, and where VPNs are not a good enough solution. So also it's used for users who need to make use of a traditional network. The traditional network features, and also for mission critical systems, such as systems that need to be highly available, such as you can use it for MPLS networks and also software as a service, such as Salesforce. So let's look at some ways to use the private gateway to establish point-to-point connections. You can create a private gateway by connecting two private networks, as I just said. Such as connecting your remote DC or your corporate office or even your physical equipment. So what cloud providers do is they can offer that direct private connection, and then via the co-location facilities, and then the data center providers can go ahead and do the physical wiring and offer a cross-connect from the cloud provider to the customer's rented facilities in the DC. Another usage is a VPC to MPLS network. As mentioned earlier, it's ideal for MPLS networks where it needs to be faster and you need a guaranteed performance for real-time apps. You can also set up private gateways to peer two VPCs to each other. that are, for example, in 2 different regions, where they need a private connection as an alternative to VPN. And it needs to be stable, a stable dedicated connection. And where traffic is also routed over a dedicated per account VLAN. The thing is, though, that admins need to set up the private gateway, as I've just mentioned earlier. But what they need to do is, when they create a private gateway, they need to set it up on both sides of the connection. So what Cloudstack then does is it creates a NIC on the virtual router. So this brings us to our problem use case. We had a client at ShapeBlue that required a large number of VPC peerings. So basically, they had a large number of isolated and web and application tiers, around about 20 tiers, that needed to talk to each other. And those requirements could not be met by a single VPC because of the high number of tiers. So what we decided to do is to use 4 VPCs to peer and talk to each other, each one to each other. So how do we actually connect these applications? So here's what we tried. First of all, we tried to peer using VPN connections. Here's a representation of how many VPN connections are actually involved when trying to peer only 4 VPCs. So to peer 4 VPCs to each other, you need 6 VPN connections, but times 2 for the connections, for each VPN connection. And so that in the end, that's 12 VPN connections. So there's quite a lot of setup involved in this approach. And it's quite involved, a lot of administration just to set this up. So the benefits of this approach is that VPN connections are easy to set up, but the problem is it doesn't scale, since we need to set up a lot of these connections back and forth. So also normal users, they can set it up themselves, so that's a positive. But since since traffic is routed via the L3 network, there's no need to configure VLAN allocations, since it's public IP based. So, but yeah, so the drawbacks are that since it's routed over the public network, it can be affected by things like security and latency. So there's also increased complexity when so many VPCs are peered, as just shown in the previous slide. So also it's compounded by the fact of having 2 connections per VPC to VPC VPN. So to set this up was a pain and a lot of admin. So also that it wasn't very stable. So what would happen is that one connection would just randomly drop, and then you manually need to bring that one up, and then another one's dropped, and so you went back and forth. So yeah, so this consideration didn't work. So the second consideration we tried is to peer 2 VPCs using the private gateway, and this shows how we plan to peer between these VPCs. So we need 6 private connections, and since you need to set up a private gateway on each side of the connection, you actually need 12 private gateways. And so next, I'll show you the benefits before I start highlighting just what the shortfalls are using the private gateway. And this approach exposed it. So the benefits of this approach is that it works well. It's not affected by the public network. You don't need VPNs, and so it's pretty stable. And also traffic is routed via the dedicated per account VLAN. But here's the limitations and shortfalls. The first drawback is that CloudStack does not automatically allocate a VLAN when you create a private gateway. The root admin needs to specify, okay, I want to use this one. So adding a private gateway requires that VLAN configuration. And since normal users are not allowed to configure VLANs, they must phone up IT every time, and the root admin must then go ahead and configure it. Also, the second drawback is that each private gateway, they require their own NIC and VLAN allocation. Now, this is because CloudStack assumes that each VPC to VPC needs a distinct VLAN. So for each private gateway that you create, CloudStack then goes ahead and creates the NIC on the VPC virtual router. So it creates a new NIC each time for each private gateway. And also, yeah, so this requires admin to specify it. And but also, the thing is that the admin must now make sure that he hasn't used another VLAN that's already used in the DC, because CloudStack doesn't allow you to use it anywhere else twice. The third drawback is that since CloudStack requires this private gateway to have its own NIC and VLAN allocation, you can't reuse the private gateway. So you can't go and say, I want to peer to more than one, but I want to use the same interface. When you want to peer with more than one VPC in the same broadcast domain, you cannot specify that you want to use the existing private gateway, as I just said. So for example, using the same NIC and VLAN, so CloudStack does not allow duplicate VLANs in the same DC, but since you cannot reuse the VLANs, you can actually start running out of VLANs if you only have a limited range. And this slide just shows how CloudStack does not allow you to use the same VLAN more than once. You can only peer with one, then you have to specify a new one each time. The fourth drawback is that there's also no way to tell CloudStack that you want to reuse the same NIC or the same interface. So if you create too many of these private gateways, you can also start running out of NIC allocations as per hypervisor maximums, or as they are reached. So this is what happened when trying to peer 4 VPCs, but you start running out of NICs on the virtual router. So in this case, we need 6 gateway connections. So that means three NICs and VLANs per VPC private virtual on the virtual router. So the virtual router could already have many NICs allocated, as shown top right over there. On S2 over there, there's you can have a public NIC, and you get a control NIC, and then for each tier that you create, it creates a NIC. You could also have already 2 peering NICs. So pretty fast you start running out of NICs. And now in this situation, what happened is that trying to peer S4 to S2, there weren't enough NICs, and it bombed out. So the next drawback is that since CloudStack requires a one-to-one mapping for each private gateway, we couldn't peer these 4 VPCs without exceeding the NIC count. So solution didn't work. So back to the drawing board. So here's something else we tried. Instead of VPC peering directly with each other, we created a VPC middleman as a router. And also, so creating this VPC over here, we didn't create any tiers for it. So that's saved on some NICs. And so we could purely just use it as a router. But the problem was that you have to manually go ahead and set up these routing tables on the virtual router. So the drawback is that it's pretty obvious that the solution was not fit for purpose because it's a clumsy requirement to make it work. And since it's not user-friendly because you have to basically hack the virtual router routing table. So another solution that would work is using an external switch or a router to handle the routing to these VPCs. So what you then do is just configure the router in a bit more user-friendly way than the previous ways we tried. But the drawbacks are costly. Buying external routers or switches, and also you need to manually then set up these external switches and routers. So that would require extra administration and setup, which is not user-friendly either. So that brings us to the proposed solutions and improvements. So how can we improve the private gateway to accommodate many VPC to VPC peerings in a user-friendly way, but also without running out of NICs? So here's a proposed solution. It's, as I mentioned earlier on, it's, we weren't 100% happy with, the previous solution worked, using the middleman, the VPC as a middleman, but we weren't 100% happy with that. So I've been chatting with some colleagues, and we had a whiteboard session just about how can we improve the private gateway. And so at the moment, there's just been this whiteboard session. There's nothing else. So I just want to share with you these ideas and hopefully get some feedback on a conference like this, and also so that it can be taken forward and put in as a feature request. So the goals are to be able to implement VPC peerings that are reusable. So where you can reuse the private gateway interfaces so that you don't run out of NICs. Also, if a VPC needs to peer with multiple VPCs in the same broadcast domain, that would be the same VLAN, that you can actually go ahead and reuse the same private gateway. So for example, Cloudstack what it will then do is use the same VLAN and not create a new NIC on the virtual router. So the VPC virtual router should actually only need to use one private gateway per broadcast domain. One private NIC, a private gateway NIC per broadcast domain. Also, the next goal is that a user should not need to specify a VLAN. So VLANs should actually be allocated automatically from the zone pool. So when Cloudstack, when a user wants to create this private gateway, it'll just be automatic. And the next goal would be all the private gateways in the same account should be able to use that same VLAN. So, and also to make it more user-friendly, normal users will then be able to create a private gateway, since there's no VLAN allocation that they need to set up because it's automatic. Also, transitive routing between indirect VPCs will not be allowed. So if VPC 1 has a direct connection with VPC 2, and VPC 1 also has a direct connection with VPC 3. That means that VPC 2 and VPC 3, they can't communicate with each other using VPC 1 as a middleman. If they want to talk to each other, they need to set up a direct connection between the two of them. Also, network ACLs must still work in the same way as it currently works. And when a VLAN gets assigned to an account from the zone pool, it cannot be used by any other account until it is released. So here's what it would look like. 4 VPCs will be able to peer with each other using the same VLAN, for example, VLAN 100 in this example. And they would be able to talk to each other. So we would have 6 connections, and each VPC virtual router will then have have 3 private gateway connections each, but they will only use one private gateway interface. In other words, just one NIC. And here's an example of how the routing table will look like. So, for example, if VPC 1 wants to talk to VPC 2 down here, it'll just find the correct interface and be routed there. So the benefits of changing the private gateway and implementing these ideas will be that the VLAN allocation will be done by CloudStack from the zone pool. It'll allow us to use the same VLAN per broadcast domain. Therefore, it'll just keep the different network ranges simpler. And also, there will be only one L3 network per broadcast domain. And it'll allow a regular user to actually create the private gateway without root admin intervention. And this will also help conserve NIC allocations, and thus allowing us to be able to peer many more VPC peerings than what we can do currently. So that's it from my side. Do you guys have questions or suggestions? Yeah.
Very good. Did you, by any chance, run VMware or something that you fix a low limit for the number of interfaces? Because we were running KVM, don't take my word, I remember running from a very specific scenario. One of the customers was running, maybe I'm lying, but almost some crazy number. 32 is theoretical number -7 for different devices. So why? I'm not sure you didn't specify the, let's say, exact number of interfaces, but the number shown on the images were pretty low. So,
yeah. I'm not 100% sure if we used the. Okay, yeah, sure. Okay.
The plans that you mentioned now, multiple bullet points for improving the situation in general looks, from my perspective, very interesting and fine. The one thing that maybe I didn't quite completely understand, and I took a suggestion there, you mentioned you mentioned there that VLAN assignment from the zone VLAN pool. So from which VLAN zone pool you do need to configure separate physical network where you actually, for example, want 0 or whatever, and then if you will provision manually, for now you manually define VLAN 100 into provision 10.100, for example. But from where do you want, from which actually VLAN pool do you want to take away, let's say, commands? Because you mentioned from zone VLAN pool, is it from the thing that was assigned to what, to VPC stuff? If you understand my question, from which pool specifically is it meant to take away specific events of one?
Yeah, that we didn't go discuss the practical application of it yet. Yeah, yeah.
Okay, cool. Just my idea was that I'm assuming actually that you as government administrator will probably want, for example, to define the specific pool from 100 to, I don't know, 200, let's say, for this specific physical network, which corresponds to a certain interface on top of which VLAN interfaces will be provisioned. So you will probably want to specify a dedicated pool for the physical network to which the private gateways will be created.
Okay.
That's just, let's say, an idea from my side.
Yeah.
And there is then a question for us poor men who actually use VXLANs instead of VLANs. We are still operating VXLANs for network isolation VPCs. That's fine. For private gateway implementation, obviously, what is there, which is VLANs, and what is fine. No special complaints there. So is there any kind of a plan to support the VXLANs simply for, again, scalability? I think to support VXLANs as the isolation method for the private gateway stuff, because it's, I'm assuming, or maybe I'm not fully correct, that it's just the method of implementing it. The same way you isolate networks and provision bonds on top of this or that for VXLANs, the same way you put implement the same stuff for private gateways, connection between the stuff. Because at the end, on the remote side, if it's a customer PC, you will just tell to the guy, please don't provision VLAN, provision VXLAN on maybe on top of some VLAN, which is what we do for PCs. So that's just a question, does it warrant any kind of user cases that you guys have to actually support also VXLAN as an isolation method for private gateways? Sorry, a long question. But
Sure. Yes, I think we will need to take it to the community and just make sure that we cover all the use cases. Yeah. Any other? Okay. Thank you guys.